Welcome to decoding the content of a record ID field. Hey, I'm Eric, and today we're gonna go on an adventure into the guts of Business Central. We have a field in Business Central, a field type in Business Central called Record ID. Record ID is this magic field that can hold the complete identifier of a record plus what table it's from. So with a record ID, you can kind of find any record in the system. It's not as popular now as it used to be because we also have the system ID field, which is more accessible because that's an open format. It's just a good. The downside of the system ID is that it's only guaranteed to be unique within the table, not in the entire system, and you cannot determine if you get a system ID, you cannot determine what table it's from the ID itself. But the record ID can do all these things, but the record ID is a closed format. It's not really something that's documented anywhere, at least what I could find, other than some old deleted blog post on the Wayback Machine and stuff like that. So I had a little adventure, and I thought, let's do a condensed version of the adventure here. So let me start. And the reason I had this adventure was that I was given a dump of data from old nav, from a database that was defunct, and instead of trying to get a nav running on this database and the right version of objects and whatsoever, the only thing that was not easily decodable was the record ID. So let's try that. So let's start here. Here is a couple of, you can see that I have just, in this case, grabbed the record link table. So you know, in Business Central, if you go and do, let's go to a vendor, and you go on the attachment, and that's behind my, but if I add a link, test vendor, test again, I add one of those, let's go back to SQL, execute, now we got another record. So the task that we want to accomplish today is that we want to decode this what is this? Well, whenever you're looking at data, raw data, there are typically some indicators of what the data is. In this case, there is a dead giveaway that this is hexadecimal data, right? You see 0x, that is the agreed upon syntax of saying what comes next are a hexadecimal value of some sort. Another one could be 0b, meaning that what comes after that is a binary value, and so on. And there's a couple of more of these, but in this case we can see that this is hex, and it's hex because that's the way that if we look at let's see if we can go do design on this table. This might be this is a var binary. I know it's hard to see, but trust me, it's a var binary. 448 bytes, which is perhaps a strange number, but let's see if we can get something out of that at some point. Anyway, so how do we go about this? So this is hexadecimal. So one thing you can do is just to wrap your head around is that instead of it says 1 2, because 1 2 is not 12. 1 2 is something else. So we could bring up a calculator. And you know, people made fun of me the other day because I used my old HP calculator from the 80s. but it did the trick. Math has not changed. So if we put 1, 2, and I have set the calculator to hex here. So if I set this to 1, 2, then we can see that, we change it to decimal. This is 18. And why is this 18? Well, you go back and say, we see the 1 and the 2. If you take this and then split it up into 2 parts, so if we look at this from binary, you see we have 4 bits. So value 1, 2, 4, and 8, 1, 2, 4, and 8. So each block can go to 16. And in this case, this is a 2. And this is a 1, but it's the second block. So in reality, this is 16, right? So this one counts from 0 to 15, and this one counts from 16 to 31. So in this case, a 2 plus a 16 is 18. So 18 is a number we know, because 18 is probably the customer table. What we can perhaps, before we conclude on that idea, is that we can see test vendor. We typed that in when we added something to the vendor. In this case, it says 17. So if we do the same thing again here and do hex 17, then we get 23, and 23 is the vendor table. So we have at this point perhaps already located the table number, but there is a problem here, because clearly we have more than 255 tables. So what if we go into BC again, and then we go to a contact? Let's do a contact and open a random contact. We do the same thing again. I do links and I say test contact. Wow, I just not type in the second field. Go back to SQL, execute this again and say, oh, now you can see that, hang on, this now says BA13 and then some 00s. We can still see, I changed the font in here. I should probably have changed it to a fixed spaced font. But what we can see already is that there are certain things that are lining up here. So that's probably gonna be, that's what we're gonna look at next. But BA13, so what is that? Well, let's put it in again, and then we do BA13. Oh no, that is wrong. There's no table called 46,635. What if we're creative, and then we do 13BA. 5050, which is the contact table, right? So something is going on here. There is apparently an order to this, and there is. And actually, I found a page here. Nobody knew that this video is going to turn into a computer science lecture, but it is a bit. So there are at least two. Actually, hang on. I'm not able to point anymore. Where is it? Hang on. It's there. The PDP-11. That one actually made some weird ordering of some of the bytes, but in general there are two ways that you can take a value and put it into memory. You can do it as a little endian or big endian, and if you have a number that is consists of, in this case, 32 bits. What is the order of the bits that are actually there? And in our case, things get lined up as the most significant sorry, let's make sure we do this right. So we have, you see, we have the least significant part of the value first, and then we, as we go along, we get more and more to it. Opposed the other way, where you have it the other way around, which looks more like math. So that's why when we typed this number into the calculator, the order of the bytes were wrong. So with that in mind, we know that we have tables up till a lot of numbers. So if we look at this, it's probably safe to say that the first 8 bytes, or the first 8 characters representing the 4 bytes, would be a 32-bit unsigned integer, which would be the table number, right? So maybe we need to let's grab the contact one, and I started a new app here, so we can do and say hex string, that's a text, and then we do hex string equal that one. And let's just get rid of the 0x, because that's not gonna do anything, because we know it's hex, so we don't need the identifier anymore. And then I looked and said, remember, Hannah, we did a video a long time ago where we were building some keys for some encryption, and we needed to turn a hex string that looks something like this. We need to turn that into to some binary data, and from that video I found 2 functions we created: get byte from hex byte and get value from hex char. So we can see here that this function takes 2, and then it takes the first one and apply 16 to that and add the second one. So and then there's a function that just take a single hex character and return the value from 0 to 15. So I guess we can try to see if we can get that to work. So if I do message table equal %1, and then we do let's just change this into get integer, and then we go get integer from hex byte, and we do hex string comma substring 1.4. So we pass 4 bytes into it. So how do we do this? I guess this get integer, maybe we still need to get a byte, actually. Get a byte. Maybe that is actually an okay way. So we get a byte from it too. Then we create another function called get integer from hex. And we do hex int, which is a text. Right now we'll just do 4, and then we'll figure out what we need to do. So this one will get a byte from 2. So I guess what we can do is that we can do exit, and then we can do get byte from hex, and then it's hex int substring 1.2. So this was just fine. Let's see if we get anything. Now we're just getting 1. I just want to see if any of all this code, you know, one of the biggest dangers in doing stuff like this is to assume that the code you copy from somewhere still works. 186. So where's our calculator? So if we go decimal, so we do 186. That is hex BA. We are clearly cooking here. And we get the usual Azure 80. Microsoft should really just change. Now that everything always hit that Azure try thing, they should change the default of this one to be exclude try. So we not every single debug session starts put a try function in Azure. Anyway, let's get rid of that. So that's pretty good, but that's not the one we want. So what we want is the other part also. So right, we need to look at the 1.3, which is more significant than this one. So we need to see, okay, now we have this one, so we need to add, and then we say get byte, wow, get byte from hex byte. Then it's our hex in substring 3.2, so position 3 and 2 characters. But that one we need to shift, right? Because each, as we go down, it gets more significant. So this one is 256 times higher than this one. So and what about the parentheses? Something is wrong here. We need one there and we need one there, and then we do not need. Is that right? Yeah, maybe. Let's give it a try. Boom, 50-50. So we are in business. We have actually now decoded the table number. But to be fair, we know that, hang on, see, so what I like to do when I have something like this and I'm trying to figure out is that let's put some characters next to it and figure out what we decode. So we know these 4 are definitely the table number. Since table numbers can be more than 50, let's do we have a production order something? I'm just clicking. You guys didn't realize, but I had no clue about production. Do I need to go in and say I maybe need to go into company information and tell that I am not essential. We knew that. I am premium. Haha. And then it starts. So let's go back and do production order list, planned production orders. Can I do a new one here? I just need a record. I can. Boom. I do a note. Hello. Prod order. And I for sure cannot remember the table number. So 99.00813. So now we have that. Let's hit back to our friend SQL. And see what we get. We get something here. I'm slightly disappointed. I thought that would be a bigger number. Am I doing this in the wrong table? Oh, 5504. Where's Is there anything I can put in a high number? Let's cheat. Remind me of a high number, very high number. Tables. What do we have that might give us? Maybe we don't. Okay, if I remember one at some point, I will go back. We got a semi-high number. So let's stay on track here. So I know that the next 4 are also the bytes for the table number. So I can do 1, 2, 3, 4, 5, 6, 7, 8. Those 8 are the table number. So we got that. What we do know, if we take a look at this one, let's go for one of the simple ones for a second here. Hex string, wow. Hex string equal, so this was 1, 2, we determined that was the customer table, right? So what we can see here is that we get, and the important part, and now I'm rambling, sorry. So Business Central is Unicode, right? So as soon as we get into certain things, we will have 2 bytes representing a character somehow. So we can see a pattern here, right? This is 3000, 3000, and we got something again. So there's clearly 4 bytes. Okay, sorry. Okay, let me a code field. Let me just do one more thing. We go back to customers. Yes, table. And then we create, you see 10,020, so we have these, right? So somewhere in here, it says something with tens of thousands. So that would indicate that we have 3000. That would be a 0 somehow. Because we need 4 zeros, and there's a pattern here where there's 3 groups of 3000. So that would probably represent the number 0. And then before that we have something more, which is a number that is 1 greater than 0. So that would probably be 1. So I would argue that this sequence somehow means 10,000. So that leaves us with, there's 6 characters here. That we're unsure of. And you can see that this one says FF and this one says 05. But if I go in and create a new customer, blank customer card, oh, that's a bug. You cannot do a blank. You cannot create a new customer in BC25 without a template. So now I'll do with C. So it starts with C. I add a test C customer. If you can hear my dog, just ignore it. Test C customer. We go back to SQL. Test C customer. So this is this one. So let's go back and grab this one. Hex string. Wow, colon equal. Boom. We get rid of this. We can see that the table is the one we know. Now we have the FF back. And here's another story lessons from old days. So this is a code field. And what is the difference between a code field and a text field, you may ask? And that's a very fair question these days. But back in the days, code fields were special, and you can see here why they're special, because it starts by having one byte, and the byte is telling the length of the content if the content is purely numerical. If not, it will say FF 255, which is longer than the original. You could have a code field B. So by adding the length at the beginning of the field, you would actually be able to sort it correctly numerical, because a length 1 value, the value 1 will have length 1, it will be sorted before length 2, which would have a 2 in front. So that's how they did it back in the days in the old database, to have magic sorting on a text field if it only contained numerical values. But we can use this to our advantage, because now we know that at least in case where the first field is a code field, this is the length of the code field. So now we have 4 bytes left here, and you can see that this one says 027B. And if we pop that into to this one, so we'll do 7B02, we get nothing. And I looked deep and high, and by it's probably defined somewhere in the DLL. I did not go that far. This is clearly the type of the field. We can when we get to, we're already at 26. This is a long adventure. When we get to this one, for instance, that was on this was on hex string equal. See, this is on 2.4, so we go 2.4. This is table 36. So in this case, we can see those 4 bytes has a different OB, 8B. So this is an integer. So we know how to decode an integer. We know that it's 8 bytes. 8 characters, I should say. 1, 2, 3, 4. And now we can see that 027B comes back here. And the primary key of the sales header is an integer and a document number. So clearly the 027B is a code field. So we know that. The only thing we're now missing in order to actually decode everything here. So we know a code field is coming. We know that if it says FF, it contains alphanumeric characters. If it says something else, 05 in this case, we know that it's a numerical that's 5 values. But we can actually ignore this byte completely, because that's an internal structure. It doesn't change the value of it. So what we have left here is, here's a byte, or here's a character, I should say. So we could do 1111, 2222, 333, 444, and 555. Hang on, let's see. Did I get this right? I did. So this was with the what was the customer number here? C00010. So there's a 1 there, and then there's a 0. So we have 6 characters here, right? So this becomes a C. Well, this becomes a 1. This becomes a this becomes a 0, and this becomes a 0. This becomes a 0. This becomes a 1, and this becomes a 0. So here we have a customer number. Okay, so now we're almost done. But so the way it works here is that the ASCII value, the binary value 0 cannot be inside a code field. So what we have here is actually a zero-terminated string. And we can see that because we have 1, 2, 3, 4, that's a 0, and 1, 2, 3, 4, that's another 0. So we have a zero-terminated string. So with that, everything is actually decoded. So let's see if we can decode this one in code also, and then I promise you the video will be over. So the first thing we need to do, just to make this proper, is that we need to make sure that we support all 8 bytes here, all 8 characters. So we will actually need to say plus, and then we'll do this one again, plus this one again. But now it's time 256. Oops, not on this one. On this one, times 256. And this one is times 256 times 256, right? So we have all the 4 ones. So if we need to make the unsigned 4 billion, if we can test, we can cheat, we can test. So we can go here and then we can do. What if we do FF here? Then we should get a fairly high number. Or maybe not. Maybe I need to make sure that it's actually the right characters I use here. Close. And now we probably ran into another issue, is that integer in BC are signed, and now we're trying to create an unsigned value. So we are clearly overflowing. This is a length because this is a text 8. Wow. There you go. Let's see. They'll probably still be mad at us. Let's see why it's mad. Yeah, overflow, because now we're building a unsigned value into a sign. So maybe, whoops, we put a single F somewhere. What about a single F here? Let's see if that is, it's probably still. We could go big integer instead as the output. Let's see how that goes. Am I screwing up right now? Maybe we are. Okay. Anyway, we're totally abandoning this right now in order for, let's just see that we are still getting position 1, position 3, position 5, position 7. Let's see that we are getting the right number out of those. Let's use the contact one again. There you go. So clearly to actually decode some of the very big numbers, we need to get creative. Anyway, so we have the table number. Now we need to decode this. So we need to get this into a character, a letter, right? So maybe we want to do a local procedure get char from hex, and we do a hex char because that's apparently the way I do this. And wow, it is a procedure. So in this case, we are kind of just doing the same thing. We're just doing this exact operation. So we do exit this, but now we are exiting this as a char. So we should be able to let's see if we can go here and then customer equal %2, and then we go and say get char from hex. Now we're just cheating, so this is position, this is 9, 10, 11, 12, 13, 14, 15. So we'll do hex string substring 15,4 plus let's do this. Normally we will put this into a loop, right? Or some clever and test when we're done. I guess this is the hold my beer moment. Customer is 260. That seems wrong. And why is it wrong? Well, right now we're actually adding a char. So maybe it's better if we return a text 1. So we need to do, let's do it like this and say, let's do it like this. Out, there's a text 1, and then we do here it says out equal out 1, because it's the char in the string equal this, and then we exit out. Almost, we're missing one character. Okay, we're gonna do the last character, and then we're totally gonna turn off the video. Customer, we got it. Ha! That was a... So, of course, we're totally cheating, but we decoded the hex, so we know how to decode. We can decode the example. So what I did in my code was that, you know, I started, you know, cheese grater slicing stuff off as I went along. So I got the table number, then I figure out what is the type of the first field, and depending on the type of the first field, I know if it was an integer field, it was 8 characters. A code field, it was cut off with the zeros. So it was just a matter of going through the motion and actually cutting these things off and processing them from left to right. And by the end of that, I had the primary key of what I needed to have and decoded my data. That's a little adventure into the inner structure and how you can end up in a situation where you need to decode and figure out what's in it and how to read it. If you want some lighter AL, this video is for you. There's probably some good tricks in that one too. I'll see you there. Take care. Bye.